One more, a priori, a posteriori. Also, I've used this terminology in an earlier room. A priori, Latin for before. A posteriori, Latin for after. Before what and after what? After experiment, after empirical collection of data. An a priori claim is a proposition whose justification does not rely upon experience with empiria. Again, example, all bachelors are unmarried. I do not need to go out in the world and check for each and every bachelor to say that all bachelors are unmarried. I don't need to do that. Whereas if I were to say all bachelors are unhappy, what I really need to do is to go out into the world and check each and every one, ask them, are you happy? Yes. Are you happy? No. Are you happy? And then make the conclusion. And I use the same example here on purpose, although it is advised sometimes not to, because they are very intertwined and they are very married, these two distinctions, and Kant marries them himself. So Kant tries to draw these distinctions, and then he says, can you have a priori synthetic? Can you have a priori analytic? Can you have a posteriori synthetic? Can you have a posteriori analytic? And then he draws the conclusion, which we will get to in a minute. So analytic, true by definition, by tautology. Synthetic, true because you have discovered something new. It tells us more than the definition. A priori, before doing experiment. A posteriori, after doing experiment. Okay? And of course, they are linked. If you think of analytic and a posteriori, so it's an analytic claim. It's true by definition, but I need to do experiment to discover it. Yeah, that doesn't sound right. Analytic sounds much more right with a priori. It's true by definition, and I don't need experimentation to prove it. Again, I must repeat what Wissam just said. This discussion is highly contested, and if you think it really doesn't make a lot of sense, because it doesn't. But for now, it looks attractive. And I promise you, discovering the problems is not as easy as we might think. So stay with me here. Analytic, a posteriori doesn't really make sense. Analytic, and then you need experiment to discover it. It's true by definition. You don't need to do any experiment. Analytic a priori fits together. Now, synthetic a priori also doesn't make sense. Synthetic means I am discovering something new that is not contained in the definition. And then a priori means I don't need experiment to do it. Well, how is it that you're going to discover something new about bachelors being happy or not, or about calculators being able to do whatever or not, or about these birds or those or not, without actually going out in the world and doing experiments? So synthetic a priori also doesn't really work. And then synthetic a posteriori makes more sense. You need to discover something new. And then you can say, oh, I'm going to add it to the previous term that I already knew. I already have a definition for. So analytic a priori goes together. Synthetic a posteriori goes together. Until we start thinking about John Mallinckrodt's question, mathematics and physics. Or at least the parts of mathematics that is used to express the physics. Is it analytic? Or is it synthetic? Is it a priori? Or is it a posteriori? On one hand, we don't need to do any experiment, or so people believed at the time. If you attended my philosophy of math room, you will know that these are not given points of views. But let's take the traditional Kantian, at the time, very dominant view. You don't need to do any experimentation to discover the truth of math. 1 + 1 = 2 without any empirical data. So on the one hand, there is that. On the other hand, if you look at most theorems that we use, those theorems tell us something new. An analytic claim about triangles, for example, would be that all triangles have 3 sides or 3 angles. Yes, that's an analytic claim. It follows from definition. It does not follow from definition, however, that all triangles, the sum of their angles, and in Euclidean geometry, of course, I'm saying Euclidean plane geometry, is 180 degrees. It doesn't follow from the definition of a triangle. We've discovered this. So how is it that we're discovering things without experiment? Kant